Okay, welcome back to chapter 2, Revisited. So, what we'll do to this day will be to present to you particular examples on the laws that we have already discussed. Okay? So, for this part, exercise 2.1, simplifying radicals, we had here before nth root of x raised to the n equals x. Here, provided that when n is even, x cannot be negative. Okay? We discussed that already before. Okay, so we have here constants. The index here is 2. So, we need to rewrite this radicand in terms of a square so that we can cancel it with this one here. So, note that 81 is a perfect square and that can be written as 9 squared. So, following that law there, we get here 9. Or the square root of 81 is 9. Let's take a look at number 2. The index here is 3. So, we need to write this as an exponent 3 here inside. Okay, note that also this radicand is negative. We can allow this to be negative here provided n there is an odd number. And 3 here is an odd number. So actually, I can take out the negative immediately and I will get here negative cube root of 125. Note that 125 is 5 times 5 times 5. Or I can write it as 5 cubed. Again, from this law, I can cancel this and my answer is negative 5. Number 3. This is square root of 1.21. If you would recall, 121 is a perfect square. 121 is actually 11 squared. If this is supposed to be a perfect square, the number of decimal places should be divisible by 2. Which means this may be a perfect square. In fact, I can write 1.21 as what? 1.1 raised to the 2. 1.1 times 1.1 will give me 1.21. And this is a perfect square. I will cancel the 2. I will get now what? 1.1. Okay, look at number 4. The decimal place is placed on the third position. So 1, 2, 3 decimal places. That should be divisible by 3 for us to suspect that 0.125 can be a perfect cube. Now again, if you have here 125, this is actually a perfect cube, which is a 5 cube. But here we have a 0.125. So you would suspect that if we have 0.125 here, I will have here 0.5 raised to the cube. Okay? Which is exactly this one here. So I can now rewrite this as cube root of 0.5 raised to the cube. 0.5 times 0.5 times 0.5 is 0.125, a perfect cube. From that law again, I can cancel this and my answer is 0.5. Okay. Number 5 here. The index here is 6. So we need a factor here so that if we multiply it by itself 6 times, then it will give us 64. That one, the number that is a candidate will be 2. 2 raised to the 6 will give us 64. So 2 times 2 is 4 times 2, 8 times 2, 16 times 2, 32 times 2 is 64. Therefore, 64 is a perfect 6. I can actually cancel this. And I will get here a 2. Okay, now, look at this. We had before a law like this. Mth root of the nth root of x, which is equal to the nth root of x. Which means I can split this index such that the inner index can simplify the one here inside. What kind of number is 64? That's a perfect square. So, I can split this index so that I will have here up square inside, and then on the outside is a cube. So this is 3 times 2 is 6. Okay, now I can simplify this. What is the square root of 64? The square root of 64 is 8. But that 8 has to be extracted a cube root. Okay, now we know that 8 is a perfect cube because I can write this as 2 raised to the cube. And from that law again, this one will cancel and our answer is 2. So, we arrived at the same answer.